All right, hey everybody, and welcome to multitasking. This is a fun topic because it's interesting to hear kind of people's own experiences with multitasking and how well they think they can multitask. So I'm going to go ahead and start out by saying that pretty much we are bad at multitasking. That is a very well-established scientific fact. That time and time again, when people study multitasking, when people study attention, the same thing that keeps being found is that people are not good at multitasking. That human beings are just not. That for the most part, we can only really meaningfully, truly, only kind of focus on one line of information at a time. More than that, though, whenever we have more than just one line of information, we either see inaccuracy, so we see interference with those cognitive processes, or we see delayed reaction time. So we see that it takes longer to do these two tasks whenever you try to do them together than when you try to do them separately. So here's a very quick, easy example of that from the early 2000s. This is just an example. This isn't the study that found it. This is just kind of an easy one to explore. So basically in this task, what the researchers had folks do is they had them do one of two tasks. The first task is to calculate whether or not the first two numbers you see add up to the third number. The second task then is going to be to report what happens whenever you multiply the first and third numbers. Okay, so basically you're doing two separate things. Now, they are going to have other conditions where you're just doing one or just doing the second one. But let's say that I want you to try to knock both these out as quickly as you can. So just give me both of these. So you're going to tell me yes or no, and then you're going to tell me what the number is. All right, so here we go. So here you should say yes, and you should say 21. Pretty easy, right? Here we go again. And here again, we should say no, and we should say 50. All right, so if you were to do that, but again, you're only picking one or two, you're either going to do task one or task two, and you were to look at, let's say, do the first two digits add up to the third, you would say yes, and you would say that very, very quickly. Or if I asked you to tell me what the first and third were, you would be able to tell me 63, you'd be able to tell me that very quickly. So whenever people have studied this, they find essentially the same thing. That whenever you have people doing single tasks, even if you take how well they do individually and add them up, generally you're not going to find that people are able to do that. When people multitask, they're not going to be able to do it faster than if you were to do them separately and then combine them at a later time. And that's what you're looking at right here. So these gray bars, this is looking at adding up the two single tasks versus how long it takes to do just the dual tasks together. And you can see some pretty huge effects, right? That it takes almost a whole second longer to calculate this stuff whenever you're doing both of them than if you were to do them separately and then add those reaction times together. All right, so sometimes people will say, but wait, I am pretty good at multitasking, or I know somebody who's good at multitasking. And there are certain ways in which you can get good at multitasking. They almost all involve automatomacy. That's not how you pronounce it. It all involves things being automatic and autonomous. I don't know. But basically, when you become an expert in something, those things that you become an expert in tend to require fewer cognitive processes. And so you might be able to get away with multitasking if you have a lot of practice in a certain specific area. But with that being said, people who do say that they are good at multitasking are usually the ones that show the worst effects of multitasking. And it's usually the people that say that they're bad at multitasking that actually have the highest performance of people whenever they are multitasking, which is kind of an interesting finding. But basically, whenever we talk about this stuff, there are some tasks that we are really, really good at. And the things that we are really, really good at typically are the things that we are best at multitasking if we have to. So one example of this that comes to mind is the ability to sing and play an instrument. And so those of you that have ever picked up an instrument, you know that it's really hard to play and sing at the same time. Those of you that have been playing for a really long time, however, though, you have no problems, for the most part, combining those two. But the interesting thing, then, is that even though that's true, you can get better at doing those two separate processes at once, it's still a better idea to just do one or the other. You'll see like in these different kinds of singing contests, America's Got Talent, or whatever. I don't even know if The Voice and American Idol are still on. I just those are the ones that come to my mind whenever I'm trying to think of these kinds of singing performance shows. That you'll see a lot of these contestants insist on using their instruments on stage while they're singing. And I think it's because they're trying to convince people that they are true artists, that they are, true musicians, because they can play an instrument and sing at the same time. Ooh la la, wow. But that's actually probably not a good idea if you are trying to sing the best you possibly can. And the way that I know this is because if you look at any performer, any songwriter, if you look at anybody and you look at how they recorded their songs, almost all of them record their songs their vocals separately than their instruments. You look at John Legend. John Legend sings and plays piano. He doesn't do both at the same time in the studio. He plays piano on one track, then comes back and re-records over it with his vocals. That's true for every rock band, pretty much, for every country singer, everybody. They all do these things separately because everyone knows that if you're trying to get the best task, then you should do it solo. You should do it by itself. You shouldn't try to multitask. All right, so here is a very cool example of automatic processes as they relate to attention. So what I want you to do is right here, I want you to start right here and tell me the color of this word. It's not a real word, I know, but tell me what is that color. If you said black, and I want you to say it out loud. It's going to be weird. If you need to move into another room to do this, you need to try this out so you can see it for yourself. But I want you to say what the color of that word is. I want you to say what the color of this word is. Green, right? So what I want you to do is to, as quickly as you can, read down the list of these words and tell me what colors they are. So I want you to actually try this. So don't just keep listening to this video, hoping that I'll move on without you actually trying it. I want you to actually try it because this is something that does work really, really well. So go ahead and try it. I'm serious. Try it if you have to. If you have to pause it, if you have to come back later, just try it. So you probably said something like, black, green, red, blue, yellow, green, blue, black, red, yellow. Very easy, right? Not hard at all. But I want you to do the same thing for column B now. So I want you to start here. Don't tell me what the word says, but tell me what color the font is. Try to do it as fast as you can. And so when people try this, usually they'll get over the first two and then they'll start stumbling. So we got, I'm going to try this too, just to show that we're going to experience something weird. We're going to slow down, we're going to mess up a little bit. We have already established that this is a very easy task because we established that in column A. We had no problems there. But now let's try column B. So, all right, so here we go. Yellow, red, green, yellow, blue, red, black, green, red, blue. I stumbled a couple of times. I had to stop myself because I got a little bit mixed up. And you know why this happens, right? Because these words are different than the words that we're thinking about saying, right? That here we're supposed to say yellow, but we see the word red. And that's called the Stroop effect. The Stroop effect in this task is requiring us to say what the color of the word is, but not the actual word itself. And so again, here we are looking at reaction times. Whenever you have all this written out in black ink, or if you have it in nonsense words like we saw previously, people are very fast at responding to this. And whenever you have the same word as the color, very, very easy. People will respond very quickly. But whenever you have an incongruent task, whenever you have the word and the color of that word as being different, as not the same, you do see people committing more inaccuracies and having slightly slower reaction times. And that shows us that essentially that reading is an automatic process, that even though we don't want to be reading, is not required for this task at all. We're not supposed to be reading. We still get caught up in it. We still can't help ourselves. We still do this. And so reading the word interferes with your ability to say the color. And this is kind of another example of the filter theory, that bottleneck that Broadbent was talking about. That essentially you have only so much information can go through at once. And so because we have these two things that are trying to happen at once, only one can really successfully go through at a time. And so we slow down. This has been established not just in humans, it's also been established with primates. Basically, they trained up these primates to respond to certain symbols, and then those symbols change colors, and this is a whole complicated thing. But if you're interested in that kind of research, it's fascinating stuff. You can find that here, publication by David Washburn from the 90s. So I want to go into some detail with this task by Watson and Strayer. This is a task that I used to have. I used to require people to read, and I'm not doing it this semester simply because I feel like we're short on time, and I only want to limit you to so many different kind of research quizzes and assignments. So Watson and Strayer several years ago came up with this task. They were interested in multitasking, and they were going to test it by having people in a driving simulator do a specific kind of cognitive task. So essentially what they're doing is they're driving along in this driving simulator. They're sitting in a driver's seat, they got a steering wheel and all that other cool stuff. And they're driving, and their job is to follow the car that is ahead of them, but not to rear end them. But the car ahead of them is going to randomly slam on brakes for no apparent reason. That's just the task. And so the question is how closely can they stay to this car without hitting the car, and feel comfortable doing so. So while they're doing that, which isn't super hard, right? You do that all the time whenever you're on the Mass Pike, driving around. While they're doing that, they are using some hands-free cell phone stuff, so they're not, they're able to just talk, and they are doing a memory task. And this memory task is essentially, you're going to see a list of words in this case, and then you're going to have to do math at the same time. You have to remember what the words are. So I'm going to simplify this. I'm going to give you letters instead of words, but we'll try it all the same so you can see what these participants went through. So imagine, I want you to remember the letter B, and then tell me whether or not the next equation that you see is true or false. So this is false. So you would say out loud, false. And then I give you the next letter. I would say P. And then I give you this equation. Is 4 by 8, 24. And again, you would say false. And then I would give you F. And then I would ask you, is 4 plus 12 divided by 4, 3? And you would say false, right? That should be equal to 4. And then we have M. And then I give you another equation. Is 2 plus 1 plus 5 times 2 equivalent to 13? And you would say true. And then I would give you the letter G. And then I would ask you to just repeat those letters in the order in which I read them. I don't even remember what they were. So if you can, congratulations. That's kind of hard though. But essentially, you're doing two separate things in this task. You're both driving, following this car, and you're also listening to this conversation and responding to it. You're trying to respond whether or not these math equations are true or false, and you're trying to remember what the person is saying. So the question here is, does driving negatively affect how well you do on this task? It's called the O-span, the operational span task. So does driving negatively affect your O-span performance? And does doing the O-span negatively affect how well you drive? As you can imagine, people are very, very interested in this because of the prevalence of cell phones and us texting with cell phones or talking with cell phones and things like that. So here are the results, and I know there's a lot of data to look at all at once, so we're going to break it down. We're only going to look at over here in this column first. We're going to look at these two figures first. So what we're looking at right here in panel A is going to be the brake reaction time for whenever people are just driving versus whenever they are doing the task and driving, which is going to be the dual task condition. So when they're just driving, you see that they're able to slam on brakes in about 1200 milliseconds. Whenever they are also doing that memory task, they're slamming on brakes within about 1400 milliseconds. So about a fifth of a second longer in order to hit those brakes. Here, panel B is looking at the following distance. We see that people that are doing both tasks at once are not able to reliably stay as close behind. They have to trail at a farther, almost 30 feet almost away compared to the people that are just driving. And then now, if we look at how well people did on the O-span task, how well people did in the specific cognitive task here, what we find is that people, when they're just doing the cognitive task, perform pretty well on it for both the memory side of things and for the math side of things. But when you have them do both at the same time, you see there is a drop. That for both of these groups, for both conditions, it drops. So people are not nearly as good when they're doing both things at once as when they're just driving or just doing the O-span. Now, there was kind of this interesting finding for this particular paper that essentially this wasn't true for every single participant, that there was a handful of participants in which this was not the case. And so you can see that here, looking at the groups versus these individuals that they called super taskers who were, and again, this is out of 200 people, I think it was maybe only 3 or 4 folks that showed this, that whenever, and again, this is basically the same data we looked at before, but we see that these individuals do not change over doing the single task versus doing the dual task. Whereas most people, their brake reaction time goes up, their following distance goes up. It doesn't for this group right here. And the same is true when we look at the O-span task, that we have these people doing really, really well on the task, no matter if they are by themselves or doing it by itself or driving with it. And the same is true for the math performance. They're doing better than we would expect, that they're not being penalized for multitasking. And why that is its own kind of area of research. This was kind of an important study because it triggered this whole area of research being done into people that are specifically good at multitasking. But again, this is exceedingly rare. We're talking 1 to 2% of the population. All right, so I think that's all that I want to talk about for this specific section. We've gone a little bit over time for what I wanted. So we're going to pick up in the final video here by talking about what's going on in the brain whenever we are paying attention. All right, so I'll see you there.